Hello, my name is Kevin Pearies. I'm a Senior Technical Sales Specialist with Expo, and today we'll be covering how to set up an OTDR. So I happen to have an FTB1 platform with an FTB 730 module, so the interfaces might vary between our different solutions and different software loads, but the idea or the setup of an OTDR will be very similar. Some of the options just might be in different locations. So let's go ahead and go straight into testing. So on the bottom left there, I'm going to select OTDR to launch the OTDR application. So you see a little splash screen here, so that'll start up and take us into the OTDR interface. So once the interface is up, you see that we are in the OTDR tab. So our OTDRs can double as a source as well. So if you need to generate a signal to do loss testing, you can do that in this area here. But for this training, we're going to stick to OTDRs. So one of the first things I want to look at is the bottom left to see what wavelengths I'm going to test. So today we're going to be testing with a 1310-1550 single mode OTDR. I'm actually going to disable 1310 for now and only test 1550 just for training purposes. Honestly, just to speed it up. And so instead of you watching both wavelengths test, we'll just be doing 1550. But in a real world test, and later on we're going to activate 1310, but in a real world test, it's important to test a short wavelength and a long wavelength. So for this particular test, I'm going to set it at 1550. We'll come back to range, pulse width, and duration as we set up the test. I'm going to go straight over here to the right where we see these three icons. So this top icon is auto. So if I were to select this icon, it actually sets this unit into auto mode. So the range and the pulse width has grayed out. So essentially all I would do is clean my fibers, plug in the fiber under test, and hit start, and the OTDR would actually go out and do an auto acquisition for me. We're not doing that right now, so I'm going to disable that. Right below that is the real-time button. So if you see here in the top right, we have this big green start button. This is the start of analysis. If I were to press this RT button, or the real-time button, it would split the start button into two pieces, and the right side would be real-time, and the left side would be an average test. And so I usually leave this checked because I'll go back and forth between the two. And right below that is the extended acquisition parameters. So this is where you can null out your launch cables. So if you have a launch cable, this is where you would null it out. And so I do happen to have a launch cable in this particular test. It's about 500 meters, I believe, or actually, I think it's actually about a half a kilometer. So we'll go ahead and input this in here when we do the actual test. If you have a receive fiber, you can input that in as well. And then down here in the advanced parameters, this allows us to tweak some of the settings, whether or not we want to do a first connector check, whether or not we want to stay in full auto mode. So if I select this and go back here to this main screen, when I hit auto, this will remain in full auto mode during every acquisition. So this locks in full auto. I'm going to go and unselect that and uncheck this because I don't want to do that today. This one right below it is using optimized range. If you have this selected while using auto mode, it'll actually automatically insert an optimized range based on the test you just did. So we'll go back over here and we have apply settings to all wavelengths. So this is to couple and decouple the settings. So if I were to select this and hit OK, and if I were to test both of these wavelengths, if you see right now, they're both using the same settings. If I change one, and then go to the other, you'll see how they don't stay the same because they're now decoupled. So if you want to decouple these and set them individually, you can do that, which is the way that I like to test. So I'll go ahead and go back in here, and we'll unselect that. And high resolution acquisition, what this allows you to do is it adds more data points or bits of information when you're doing a test. So if you want to maintain higher resolution at longer distances, you would select this, increase the averaging time a little bit to hopefully allow you to test further with better resolution. That's what this allows you to do. Over here on the right is where you can tweak your custom parameters for the range and the duration knob. So over here you'll see the range and duration settings. If I wanted to create a custom distance, I doubt very much I'm testing 260 kilometers ever. I can go in here and say create a custom event that is half a kilometer long. And so if I go back into here, we now have a half a kilometer range. This is actually very useful if you're testing very short distances, say a couple 100 feet, 500 feet, you can go in there and input some very short distances to optimize the range or the view of your display. So I'm going to go ahead and go back in here and just reset this back to default. I just wanted to show you that because I think it's very useful. Go and hit OK. And we'll come back to this screen to null out our launch cable. So over here to the right, we have our different menu options. So anything under File is what allows you to manage or manipulate the file. So opening an existing trace, saving one you just did, generating a report. So we'll come back and do that later on. So this allows you to do a test and then generate a PDF report of that test that you can send to anybody. So go back to home here. Identification is for setting up the identifiers. A location, B location, fiber ID, all that good stuff. And again, we'll come back here as well. The actual test configuration. So I can get in here and I can set my index of refraction. I can set my end of fiber detection thresholds, those types of things. And so when I do the actual test, again, I'll be back into here and we'll step through this real quick. And then user preferences is useful if you want to change this into different units. So kilometers or footage, depending on how you prefer to see your units. And this is where the actual test is saving right now. If I go into report, we can manipulate what we see on that PDF report that I talked about. So it's just all user preferences in that regards. So I'm going to go in here and just do a quick test real quick for you. So I have a network simulator plugged into my fiber. Actually, I have a launch cable, which is about a 0.5 kilometer long, from my OTDR into my network under test. And so if I were to do just a quick little auto test, so I'll hit auto here and let it run a quick test, we can get a good idea of what my length and what my network looks like. And again, this is just a quick auto test. So to go in there, it'll set the range and the pulse width and then give us a view of the fiber. So I want to do this for two reasons. One, to see what the length of my fiber is. My records say it's this long, but is it actually that long? So this is what it looks like. My actual fiber here is about 18.5 kilometers long here. And if I were to zoom into this portion here, I'm going to go ahead and zoom into the launch here. This is my OTDR right here. So this bracket means start of analysis, and this one here on the end means end of analysis. And so I'm going to zoom back into where I was at. This is the OTDR port. This is my launch cable, and this is my network under test here. So I don't really want this portion here to be part of my test. So this is 0.5123 is the distance from my OTDR to the end of my launch cable. So 5123. So what I'll do here is I'll go to the OTDR tab. I'll go here, and I will set my launch cable based on that distance. So again, it was 5123, correct? So I'm going to get in here, set 5123. Hit OK. And so now, when I do another test, you'll see that our brackets move out to that very first event there. So this event right here, this reflective event, is my connector. So if I were to zoom into that, you'll see that we've moved this start of analysis bracket out to the end of my launch cable. So now we have basically referenced this out. So this is now my first event and my zero location. So it's event number 1 and my zero location. If I were to scroll back, you can see it's grayed out. This is my launch cable here. So we're no longer taking into account any of these readings or measurements, which is ideally what I want to do. So now that we've done that, we don't need to do this again. So if I'm using this same launch cable over and over, I just do this once, kind of set it and forget it type of thing, right? So now I'm going to jump back into the identification tab here, and I'm going to set up my test. So whatever identifiers I want to use, this will be part of my file naming. If you look down here at the bottom, you'll see it's fiber1.trc. So when I save this trace, that's what it's going to be named, which doesn't make a whole lot of sense to me. So I want to populate this as much as possible. So if I have any information here, so if this, has a project name, Acme project or whatever, you can input your company name, customer information. So we're not going to step through all of this. I do like to put at the bare minimum location A. So in this case here, we'll just call it Central Office 1. And then for location B, we'll call it Central Office 2. Pretty simple. And so we're testing from Central Office 1 to Central Office 2 on the Acme project, or the Acme job ID. From A to B, our fiber ID is fiber number 1. So if I was starting at fiber number 13, I would put 13 here, and I want it to increment. But you notice all this information, my file name still has not populated. So if I want to include any of these identifiers in the name, I can do that. So now it is Acme, Fiber 1, Central Office 1 to Central Office 2. So this makes a lot more sense. I'll go ahead and hit OK. Now you'll see down here at the bottom, this is what my next file name is going to be when I save it. So I don't need to do any more of the identifiers. I'll go into test configuration here. If I need to set the index of refraction, which is basically the speed of light in that particular material, this is a piece of information that you would get from the fiber white sheet. You could input that here. If you don't know it, just stick with default for now. This should cover most of, or be close enough or accurate enough for most of the testing you do with single mode fiber. If you do know this index of refraction, if you have that information available, it's good to go in there and populate that for the highest level of accuracy. So in this case here, I'll just leave it right at default. Over here to the right is detection threshold. If I'm testing through a splitter, say a 1x32 splitter, it has about 14 to 18 dB of loss. I would want to increase my end of fiber detection threshold to test past that. So what this means is anything greater than 5 dB, call it the end of fiber. Of course, if you have a 14 dB loss, that is not the end of fiber, that's just a splitter loss. So we can change that. Typically, I'll leave this alone unless I absolutely know that I need to change it. If I want to set any thresholds, pass-fail thresholds for connectors, for splices, I can do that based on wavelength. So in this case, I'll just leave everything at default. We don't need to go through it all, but this is where you would do that. So essentially what I did was I went in there, did a quick auto test to determine the length of the fiber and to null out my launch cable. We've done both of that. I went into the identification to name my fiber. I've gone into the test configuration to input any advanced configuration settings that I would like. So the only thing I have left to do is select both of the wavelengths that I want to test and then optimize these settings. So here is how I shoot an OTDR trace. I will select both wavelengths. I will hit auto and I will start a test. And essentially what I'm doing is I'm letting the OTDR determine what it thinks the best settings are. So it will set the range and the pulse width based on those. And so this is a good starting point for me. So I start off with auto, then I tweak from here. So I can already tell that I'm not using the most optimized resolution here. And so auto decided to use 40 kilometers for both of these wavelengths. So at this bottom graph display here, we go all the way out to 40. But my end of fiber is right here in the middle, just under 20 kilometers. So I can get away with setting this to 20. So I would set both wavelengths at 20 kilometers, and this will push this number all the way out to the end of the display. I don't need to touch this anymore. Pulse width is the length of the pulse. The longer the pulse width, the further you can test, but you sacrifice resolution. So the further you want to test, the further apart the events need to be detected. So one thing that I always like to say is if I can see an event at 30 miles, there's no way that I will see a splice 30 feet away from my OTDR. And so, and conversely, if I can see a splice at 30 feet, I probably am not seeing one at 30 miles. And so you need to be able to optimize this pulse width. The OTDR selected 100. I want to get this as low as I can and still have a nice clean trace. So I will drop this down to 50 and then retest. So for duration, I'll leave it at 5. This is how long you want it to average out. I'll go and hit start and then let it run the test. So you'll see that the distance or the range is nice and optimized. Again, we're not touching this again. So it's going to test both 1310 and 1550. And at 50 nanoseconds, we have a nice clean trace at 5 seconds. So I'll drop this down to 30 nanoseconds and hit start. So essentially what I'm trying to do is I'm trying to see how low I can go with the pulse width and the duration and still have a nice clean trace. And ideally what I'd like to do is have the shortest possible range, see the end, see the noise, have the shortest possible pulse width, so I have the best spatial resolution in the least amount of time. And so these two usually have to play off each other. So it might get to the point where 5 nanoseconds with a 5-second duration, it just doesn't clean up. I have a little bit of noise at the end. And we'll see if that's going to be the case in this network. And so if I really want to stick with 5 nanoseconds, see how noisy that is? If I really want to stick with 5 nanoseconds, I can try increasing the duration to see if it cleans up for me. And so this is a pretty dirty trace. And so if I want to get away with the best resolution possible, I can try increasing this up to say 45 seconds to see if the noise cleans out better. And in this case, I don't know if that's going to happen or not. We can start it to see what's going to happen. But essentially what you're doing by increasing the duration, you're increasing the averaging time. You're allowing the test to clean up the noise. And so you can already see at 1550 that this is quite a bit cleaner than it was before, just by increasing the duration. And you see it's not cleaning up much at all after this. So really much after about 15 seconds, we're not gaining a lot of benefits, not at 1550. Now 1310 on the other hand might see some benefits with the increased time, because 1310 is lossier, so it might use a different pulse width, so it might need more time. So we'll let this finish out, and then it'll switch to 1310, and I won't let it run another 45 seconds here. I think you get the point. So by increasing the duration, we're allowing the noise to clean up a little bit more. So I'm able to get away with a 5 nanosecond pulse width at 45 seconds or 15 seconds, just by allowing the noise to average out more. And again, I'll go and stop it because I don't want to sit here and stare at it for another 30 seconds. But you get the idea. And so these are the three main settings. Range is pretty much a no-brainer. I want to see the end of fiber. I want to see the noise. And then pulse width and duration, you tweak them off each other. If you're testing an 864 count fiber, you probably don't want to test 45 seconds per wavelength. That could be a substantial amount of investment in time, unless you really want to optimize the resolution. So in this case here, I might go up to say 10 nanoseconds and 10 seconds to see if it cleans up for both wavelengths. I'm sacrificing some resolution, but I'm optimizing my duration a little bit. And so from a CapEx, OpEx perspective, that trade-off might be sufficient enough for me. And if I'm happy with these settings, all I do is save and go to the next fiber. And because I set incrementation on fiber ID, the next file name will be fiber 2, fiber 3, fiber 4. So in this case here, we're seeing a little bit of noise still at 1310. So if I go to next wavelength here, we'll see that we do have some noise here. So I wouldn't go with this trace normally. I would probably go back to the OTDR here, maybe increase my duration or increase my pulse width to see if I can get away with a better trace. So in this case, I increase my pulse width to 30. If I drop my duration down to 5, maybe I can offset each other. I lose some resolution, but I gain another 5 seconds or 10 seconds per test. So 5 seconds at each wavelength. So there was 1550 and now 1310. And 1310 is a lot cleaner. Still a little bit of noise there, but it's doing a lot better than it was before. And so if I'm happy with this, I would hit save. It would automatically save the trace. And then you'll see the next disappear here. Now it just says file name. And then now I'm testing fiber number 2. I would inspect and clean my connector as needed and go to number 2, number 3, number 4. And I'm just saving data. That's all I'm doing now, is testing and saving. So it's all routine from here on out. And you'll see how easy that was to set up. I mean, it's really not that difficult to set up an OTDR. The difficulty is really in the interpretation more than anything else. And so speaking of interpretation, you do that in the event tabs. So in the OTDR tab, we were setting all of the settings, range, pulse width, duration. The event tab, this is what allows us to look at the actual key performance indicators of the different events. So here's our launch. So we're launching 0.5 dB of loss at that connector. So this is basically my patch panel, or my very first connector in my network under test. This is a little high. We usually want a half a dB or better. Reflection-wise, we have neg 53.5 dB of reflection. This is a UPC connector on the far end, so I would expect 50 to 55 at spec, so I'm really good here. I usually prefer it to be above about a minus 45 dB for a UPC connector or better. Here at 6 kilometers, we have an event. This is a non-reflective event, meaning we have loss but no reflection. This could be a splice. Here at event number 3, we have a 0.3 dB loss, and it's red because of the thresholds that we have set. And so again, this is all for 1550. So basically, this is just analysis here, right? And then here's the end of fiber. So at event number 3, at 0.3 dB, we can go to next fiber here, or next wavelength, and this switches to 1310, and then we can see what that looks like. And so then it's just all analysis after that. Analysis isn't saving. And so these files, when they do save, they're saving as a .trc. If you want to generate a report, say in a PDF to send to somebody, we can do that easily. So with this loaded and saved already, I would just hit report to generate a report. So it's going to save it as Acme Fiber 2 CO1 to CO2, and here's where it's saving. I can save it directly to a removable media if I have it. So in this case here, I have a USB thumb drive inside of the FTB1 platform. I can save it directly to that and then use email client to import it. But in this case here, I'll leave it in the default location. And so if I hit report, again, I'm going to save it to this default location here. I'm going to hit save, and it will save this actual trace as a PDF. And then all I have to do is manage this PDF, send it out to an engineer or my supervisor to review the data, and they don't have to have the viewer software. So it really is pretty handy. And once everything's saved, if you want to know where it's at, essentially on the front of the unit, we have an Alt-Tab button that allows you to get back to the setup screen. So you can Alt-Tab back to that. In this case, I'm just going to close this out so I can show it to you. But here's the main module selection screen. You'll see on the right here where it says File Manager. If I select that, this will launch a Windows File Manager. So you're familiar with this. And we are doing an OTDR test. So the default location for the report should be an OTDR. And then here's the actual trace that I saved. And then here's the report that I generated. So I didn't save that second fiber trace, but I did generate a report. So if I click on this, it will fire up a PDF. So if I were to zoom into this, you'll see what it looks like here. So here's a report, and this is just a standard PDF that you can send out to anybody. And so from this point on, I can just go edit, copy the folder, have it send to the removable drive, and now my report is on a thumb drive that I can hand over to my supervisor. And it's as simple as that. And that's OTDR testing in a nutshell. I mean, it's real simple. I mean, there's obviously some additional advanced settings and tweaks and marker placements and whatnot that is very useful. But again, the intention of this training was just to get you up and running to do a quick OTDR test. And so we'll have some additional content that you can view to get more into advanced analysis, placing markers, those types of things. So thank you very much for joining us in this session on how to set up an OTDR test. Thank you very much.